in number patterns, there are some sequences that we have been given and some that we derive when we are given in the question. So the first one that we are given is the arithmetic sequence. In this, a common difference, a number which is called the common difference, is added to a number to get the next number of the sequence. The formula for this is Tn is equals to a plus n minus 1 t. A here is the first term and d is the common difference. So for example, if 3, 7, 11, 15, 19, if this is an arithmetic sequence, the common difference here is found by 7 minus 3, subtracting a term from the next term. This will be 4. To find, for example, the fifth term, t5 is equals to a, which is 3, plus n, which is 5, minus 1, and d is 4. So this would be 19. The next sequence is the geometric sequence. In the geometric sequence, a common ratio is multiplied to the preceding number to find the next number. For this, the formula is Tn is equals to a, which is the first term, into r, which is the common ratio, to the power n minus 1. For example, a geometric sequence would be 16, 8, 4, 2. Here, to find the common ratio, we will divide a term by its preceding term. So r is equals to 8 upon 16, that is 1 upon 2. Or if we take 2 and 4, so 2 upon 4 equals to 1 upon 2. Now to find the third term, t3 is equals to a, which is 16, into r, which is half, to the power 3 minus 1. This will be equals to 4. The next sequence is the perfect square sequence. For example, if we have a sequence 1, 2, 1, 4, 9, 16, 25. The general formula for the term number over here would be n square. Now for example, if you have to find the third term in the sequence, 3 square would be 9. Fourth term, 4 square would be 16. But if, for example, the sequence starts from 4, then the general formula would be n plus 1 whole square. So if you have to find the first term, there will be 1 plus 1, which becomes 2, 2 square is 4. For the fourth term, which is 25, it would be 4 plus 1, which is 5, 5 square is 25. If the sequence starts from 0, then the general formula for the term would be n minus 1 whole square. These are the perfect square sequences. Now the perfect cube sequences. One, 8, 27, 64, 125. Here the general formula for the term would be n cube. If we take the first term, 1 cube will be 1. Second term, 2 cube will be 8. Third term, 3 cube will be 27. Now if the sequence starts from 0, then the term number will be n minus 1 whole square. So if we have to find the fourth term, which is 27, we'll have 4 minus 1, 3 whole cube, 4 minus 1, which is 3, and then 3 cube is 27. If the sequence is 8, 27, 64, 125, the general formula for the term will now be n plus 1 whole cube. Now the last sequence that we are given is called the triangular numbers. Here there is a difference between the numbers which is increasing by 1 each time. The sequence is 1, 3, 6, 10, 15, 21, and so on. So if we see over here, the difference between these is 2. Here it's 3. Here it's 4, 5, and 6, and so on. The formula for this is Tn equals to n plus 1 upon 2. This is the first question we're going to do. A series of diagrams using 3 types of triangles is shown below. The triangles are gray, white, or black. The table below shows the numbers of each type of triangle used in the diagrams. Complete the table for complete the column for diagram 4. So the table gives us the number of gray triangles, white triangles, and black triangles. The number of gray triangles in square 4, diagram 4, are 1, 2, 3, 4, 5, 6, 7, 8. So here we'll have 8. Number of white triangles: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's 16. And then black triangles: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. The next part says, by considering the number patterns in the table, find in terms of n expressions for x, y, and z. X is the general formula for this sequence. Now here we can notice that there is a common difference of 2 between each term, and the first term is 2. So we will apply the formula of arithmetic sequence here. X is equals to a plus n minus 1 d. X is equals to 2 plus n minus 1 2. X is equals to 2 plus 2n minus 2. So x is equals to 2n. In this sequence for y, we can see that each number is a perfect square number. 1 is the square of 1, 4 is the square of 2, 9 is the square of 3, 16 is the square of 4. And as it is starting from 1, the general formula will be n square. You can check this as if n is 1, the answer would be 1. If n is 2, the answer would be 2, and so on. For z, there's a difference of 2 and then 4 and then 6. So we don't have a formula for this sequence, and we'll have to derive that by interpreting this information. So here we can see that the number of black triangles is y minus n. Like 1 minus 1 is 0, 4 minus 2 is 2, 9 minus 3 is 6, 16 minus 4 is 12. So we can say that z is equals to y minus n. Y is n square, so z is equals to n square minus n. This is the next question. The diagram shows the first 4 rows of a pattern of numbers. Row 1, row 2, row 3, row 4. The table shows some results obtained from this pattern. The first row shows number of numbers in the row. In row 1 there are 3 numbers, row 2 there are 5, row 3 there are 7, so on. The next row shows product of the first 2 numbers in the row. So 1 into 2 is 2, 2 into 3 is 6, 3 into 4 is 12, and so on. The next row shows sum of all the numbers in the row. 1 plus 2 plus 1 is 4, 2 plus 3 is 5, plus 2 is 7, plus 3 is 10, plus 2 is 12. 3 plus 4 is 7, 7 plus 3 is 10, 10 plus 4 is 14, 14 plus 3 is 17, 17 plus 4 is 21, 21 plus 3 is 24. The last row shows the middle number in the row. Here it's 2, again 2, then 4, then 4. The first part is asking find the values of P, Q, R and S. This is P, Q, R and S. This is for row 5. So here there are 3 numbers, then 5, then 7, then 9. We can see a sequence over here which is arithmetic, as there is a difference of 2 numbers in between each number. So P should be 9 plus 2. P will be 9 plus 2. P is equals to 11. Q. In this sequence, there is a difference of 4, then 6, then 8. So next there will be a difference of 10 because it's 4, then 6, then 8, then it should be 10. So Q will be 20 plus 10. Q is equals to 30. R, the sequence for R is 4, then 12, then 24. There's a difference of 8 over here, then 12, then 16, 8, 8, then 12, then 16. So there's a difference of 4 between each of them, so the next difference should be 20. So this will be, R will be 40 plus 20. R is equals to 60. For S, it's 2, then 2, then 4, then 4. Next it should be 6. Now they have asked for find expressions in terms of n for x, y and z. X, y and z. The general formula for x is an arithmetic sequence, as there is a difference of 2 between each number. So x is equals to a, which is 3, plus n minus 1, difference is 2. This will be 3 plus 2n minus 2. So x is equals to 1 plus 2n. Now to find y, we can see that the difference between numbers is increasing by 2 each time. So there isn't an obvious pattern over here. We'll have to derive a formula ourselves. This row shows the product of the first 2 numbers in the row. So the first numbers in each row is equal to the row number, which is n, and the second number is 1 greater than that. So if we consider the first number as n and the second number as 1 greater than that, so the general formula for this can be n into n plus 1, or n square plus n. Now for z, we can see that each number of z is twice that of y. This is 2 times 2 is 4, 2 times 6 is 12, 2 times 12 is 24, 2 times 20 is 40. The general formula for y was n square plus n. The general formula for z can be 2 times n square plus n, or 2n square plus 2n. The next part in the question says, write down the middle number in row 101. Here we can see that the middle number in the first two rows is 2, in the next two rows it's 4. So we can see that the first two numbers are 2, this is equals to the second number, and then it's 4 equals to the second number. So 101, the middle number of row 101 would be 1 more than 101 because the even number would be 102. So the middle number should be 1 or 2. Next question. Small triangles are formed by placing rods between dots as shown in the diagrams. Complete the table. Number of small triangles in the first diagram is 1. The second diagram there are 4. Third diagram there are 9, and then 16 in the fourth diagram. So we can see that these are all perfect square numbers. 1 square, 2 square is 4, 3 square is 9, 4 square is 16, and then 5 square would be 25. Number of dots, there are 3, then 6, the difference is 3 over here. Then 6 till 10 the difference is 4, 10 till 15 the difference is 5, now the difference should be 6, so it's 21. Here it's 3, then 9, then 18, then 30. So 3 plus 6 is 9, 9 plus 9 is 18, here your difference is 6, now 9, then 12. So the difference is increasing. Difference between 30 and 18 is 12. Difference is increasing by 3 each time. So now the difference should be 15. So 30 plus 15 would be 45. The next part is find an expression in terms of n for the number of small triangles T formed in diagram n. Here we can see that all the numbers are perfect squares. So the general formula for T will be n square. For diagram 1, n square would be 1. For diagram 3, 3 square would be 9. For diagram 5, 5 square would be 25. So T is equals to n square. The next part they're saying, given that R is equals to D plus T minus 1, find the value of n when D is equals to 561 and R is equals to 1584. So R is equals to 1584 equals to D is equals to 561. T is equals to n square. We'll write n square over here and then minus 1. Now 1584 minus 561 plus 1 is equals to n square. N square is equals to 1024. So n is equals to under root 1024. It's 32. As it is paper 2, so we can use a calculator. So n is equals to 32 over. The next part says the n term of the above sequence is half n plus 1. Hence find an expression for r in terms of n. R is 3, 9, 18 and 30. This is R. If we compare these two sequences, I'll write it here. 3, 9, 18, 30 and then 45. If we compare them, this is 3 times 1, this is 3 times 3, this is 3 times 6. So we can say that r is equals to 3 times half n plus 1 is equals to 3 upon 2 n plus 1. This is r. Now how many rods are there in diagram 15? So r is equals to 3 upon 2 into 15 to 15 plus 1. So that is 360. Now the next part is find an expression for d in terms of n. In part C, we were given that r is equals to d plus t minus 1. So r is equals to d plus t minus 1. So d is equals to r minus t plus 1. R is 3 upon 2 n plus 1. T we found in part B was n square minus 1. We simplify this to get the expression for d in terms of n.